Number 21, project manager estimates that a project's going to take X hours to complete, where X is bigger than 100. So we know that the job's going to take more than 100 hours. The goal is the estimate to be within 10 hours of the time it actually took to complete the project. If the manager meets the goal and it takes Y hours to complete, which of the following inequalities represents the relationship between the estimated time and the actual time? So the estimated is X and the actual time is Y, according to up above. So what's the relationship between those two? Well, first of all, they said X had to be greater than 100. So X is a number like 101, 102. So I don't see any way when you add up how long the estimate was plus the actual, it can be less than 10. So that one's just completely out of there. B and C aren't really making any sense just right now, but let's just kind of think about it this way. If he's got to be within 10 hours, that means he could be over 10 hours or under 10 hours. So this bottom one's kind of intriguing me because it's between these two numbers. And Y minus X, let's just look at what that is. Y minus X would be the actual time subtract the estimate. And as long as that answer right there is smaller than 10, or larger than negative 10, I think D is going to be the correct answer for this one. And let's just pick a couple numbers. Let's just say that, if X had to be bigger than 100, let's say that we estimated it was going to be 105. Well, if the actual was longer, let's say that the actual was, I don't know, like 115. Well, when I subtract those two, when I do the actual, take away the estimated, that would be the actual minus the estimated. That's fine because that number is 10. And I mean, technically it's not within our window because we don't have an equal to bar there. But if we did like, 114.9 or something, we would be within the zone. Now, where the negative 10 comes out is, let's say your estimate was too much. So let's say that the actual came out to be, say it was 95. Well, or let's say it was 96, just so it fits in our interval. If we have Y, the actual was 96, take away the 95, well, when you take away, that's going to be a negative 9, but we still are okay because we're within that 10 window. So the correct answer here is D. Number 22 and 23, kind of a extended response problem here. So we have some sort of an equation. Let's kind of jump in and see exactly what that represents. So we have I equals P over 4 pi r squared, and R is the distance from the antenna, I is the intensity, and P is the power. So we kind of have that equation relating power, radius from the antenna, and intensity. So it says, which of the following expresses the square of the distance from the radio antenna in terms of the intensity? So basically, you look at all these, they're r squared. So we need to resolve the equation up above for r squared. So let's take a look at it. Right now we have I equals P divided by 4 pi r squared. So the first thing I'm going to do is I'm going to clear out that fraction. I'm going to multiply both sides by 4 pi r squared. So I'll multiply that side, which is going to cancel these two. I'm going to multiply this side. So now we're down to there. So I just have 4 pi r squared I equals P. And then to get r squared by itself, all I do is, since this is all multiplication over here, I'm just going to divide by everything besides the r squared. 4 pi I. And these all go away. And boom, I got r squared equals P over 4 pi I. So that matches up with the correct answer, B. So that one wasn't too bad, just a little bit of rearranging. So number 23, for the same signal emitted by the antenna, observer A measures the intensity to be 6 times larger than B. The distance of the observer A is what fraction of the distance from B? So if observer A, it's way more intense, then he must be closer. So observer B must be further away. And we're trying to figure out, what fraction, how much further away are they? So let's kind of take a look at this. So observer A has this intensity that's 16 times the I. So his intensity is 16I. And so we need to figure out what's going on with his radius. So we have P over, 4 pi r squared. In our original equation, we had the intensity was P over 4 pi r squared. So how can we get, how in the top equation, we have a 16 multiplied by there. Well, if you multiply 16 by one side, you have to multiply 16 by the other side. So how could that have happened? How could we have had a 16 over there? Well, it looks like if R would have been, so I'm kind of looking through these numbers here, if R would have been 1/4, if you'd have had 1/4 of R squared, that would be 1/16 down there on the bottom. And so if I had 1/16 down there on the bottom, I would have had to multiply by a 16 on the right and multiply by a 16 on the left to make that come out to be the same. So I believe the correct answer for this one is A, 1/4. That's the only way you're going to get a magnitude or a factor of multiplied by 16 on both sides. Because if the bottom was 1/4 and you square it, that's 1/16. So to get back to where you were, you'd have to multiply by 16. So the correct answer there is A. All right, number 24 is a pretty involved problem. It's the equation of a circle, then there's completing the square kind of built into here. So let me first break down the equation of a circle. So if you want to find the equation of a circle, the key formula is x minus h squared plus y minus k squared equals r squared, where in general the center is at h comma k and r equals the radius. So let me give you an example. So this has nothing to do with the problem, I'm just setting up an example. So let's say we saw something that said, hey, x minus 4 squared plus y plus 3 squared equals 25. I could tell you quite a bit about this circle. I can kind of use this fact here that 4 must be the x-coordinate for the center. And then over here it's a little tricky because you see it's plus 3. So that 3 must have been a negative because the formula is built for y minus k. So you have this y minus a letter. So the only way to get y plus 3 means k must have been a negative, because that way you get minus a negative. So the big thing I kind of think about with circles are it's opposite. So even though I see a negative 4 here, I know it's positive 4. And when I see a positive 3, it's negative 3. So that hooks me up with my center. So 1, 2, 3, 4, down 3. So there's the center. And now the size of this thing, if r squared is 25, I have to take the square root, and I'm like, oh, the radius must have been 5. So then I go out 5 in each direction, and kind of put a circle there with a radius of 5. So that's a little bit of background on the equation of a circle. Now, unfortunately, they don't give me everything that I need for this one. They set it up kind of weird. So here's how I'm going to set mine up. I'm going to first rearrange my terms where I have x squared plus 4x, and I'm going to leave a blank here. And then I'm going to put plus y squared minus 2y, and then I'm going to leave a blank there. And then I'm going to have equals negative 1. So I'm going to put that in there. All right, so now that we have this set up, we're going to have to do something called complete the square. Because remember, at the end of this thing, I want to have x something squared plus y something squared equals the radius squared. And, this is going to give me the center, and this is going to give me the radius. So in order to be able to get those into perfect squares, I need to do what's called completing the square. So how you do that is you take this middle term, this plus 4, and you chop it in half, which would be a positive 2, and then you square it. and you put it in this box. So 2 squared is, well, I'm not going to write 2 squared, I'm just going to write 4. 2 squared is 4. And then I do the same thing over here. I take that middle term and I cut it in half, which is -1. A -1 squared, or a -1 times a -1, is a +1. So now basically what I've done is, if you look at this expression right here, it's a perfect square. It's x plus 2 squared when you factor it. Plus, well, this expression is y minus 1 squared. And then I got to be careful right now because I just added 4 and I added 1 for a total of 5 to the left-hand side of the equation. So I also have to add 5 to the right-hand side of the equation, which -1 plus 5 gives me a 4. So now I kind of see what's going on here. It looks like that the center of this equation is at, remember, it's opposite. The center's at -2 and the center's at +1. And then my radius, well, if the radius squared is 4, when I take the square root of both sides, that tells me that the radius is going to be 2. So that one, the correct answer there is 2. Pretty tough problem. Number 25, the graph of a linear function or a line has intercepts at a, 0 and 0, b. If a plus b equals 0, so this is a pretty important clue right here. If a plus b equals 0, and a is not equal to b, which of the following is true about the slope? Positive, negative, 0, undefined. So remember, positive slope goes up left to right, negative goes down left to right, a 0 slope is horizontal, a undefined slope is vertical. So you need to know what the slopes look like. Well, let's just start picking some numbers, man. Let's get this thing set up. My favorite method, just pick some of your own numbers and plug them in. So I need to make sure a plus b is 0. So maybe let's put a is 2 and b is -2. So a is 2 and b is -2. Well, now we put those two dots on the grid, 2, 0 and 0, -2. Well, there's a line that goes through those 2 points, and to me that line looks like it's positive. So I believe the answer is A. But let's just, we're not quite sure. Let's throw in a couple more numbers. Let's switch it up. Let's maybe make A be -3 and B be +3, because that adds up to 0. So A is -3 and B is +3. Well, let's graph that. A -3, 0 means go left 3, stay at 0. 0, +3 means we're going to go up 3. And once again, the line is going positive. So I believe the correct answer here is A. All right, number 26, looks like we have a graph. I usually don't like these type of questions because I see that there's 3 choices and then they say, oh, something only, or 1 and 2, or all of the above. I kind of hate these kind, but we're going to have to battle through it. We got no choice. So the complete graph of the function f is shown in the plane above. Which of the following are equal to 1? So remember, y is f of x. Those two are interchangeable. So when they want to know what f of -4 is, that basically says, hey, find y when x equals -4, or find y when x equals 3/2 or 1.5, or find y when x equals 3. That's what we're trying to do. So let's go find these y's. So when x equals -4, -1, -2, -3, -4, when x equals -4, it looks like y does equal 1. So there we go. Well, when x is 1.5 or 3/2, that's 1, 1.5, it looks like the y value is 1. And then for the last one, f of 3, well, when x is 1, 2, 3, the y value is 1. So it looks like it says, which of the following are equal to 1? All of these guys are equal to 1. So the correct answer here is D. All right, number 27, kind of like a science experiment on this problem. So we have an insulated and a non-insulated cup, and I'm going to just kind of color code this a little bit. The insulated, which maybe is like a Yeti, That one on the chart are these squares, so it's kind of dropping down, like that. The non-insulated would be like, a really cheap cup that doesn't have any special vacuum sealed walls or anything like that. So this is just some sort of a cheap cup that's non-insulated. Well, let's read the paragraph, see what happens. So 2 samples of water are heated. They start at 60 degrees. So that's why our chart, both the black and the blue dot, starts at 60. Then they pour part of it in the insulated, part of it in the non-insulated. They then give them 70 minutes to cool. And every 10 minutes they track it to see where it's at. Room temperature is 25, so eventually, it gets down there. So let's kind of look and see what happens minute by minute, or 10-minute interval by 10-minute interval. So in the beginning, the first 10 minutes, the Yeti drops, but not near as much as the insulated, the non-insulated. The cheap cup, the non-insulated, dropped all the way down to just above 40 degrees Celsius. The Yeti's still above 50. All right. Well, then, as it keeps going, it drops some more, and then some more, and then some more, some more. So it looks like the Yeti, it drops every single interval, but it's just dropping less and less and less. Now, the insulated dropped really fast at first, dropped super fast at first, then drop, but then drop, and then eventually it kind of just flatlines. So different things are happening on different parts of the curve. So this is kind of like my summary here. In the beginning, the non-insulated dropped fast, okay, and the Yeti dropped slower. But then as you got towards the end over here, the Yeti is still dropping, where the other one has pretty much stayed the same. So the Yeti's actually dropping more per 10-minute interval, but it's still the temperature's still warmer overall. So let's go down, let's kind of read through the answers. I'm probably going to redraw that chart again just to kind of make sense of what's going on. So just really fast here, I want to sketch what we had. So here's our graph, and I'm not going to be perfect, but the Yeti kind of did something like this, and the non-insulated dropped much faster and then kind of flattened out. So, I could read through all of these. I'm going to kind of jump to the one that's the correct answer. Correct answer here is D, because from 0 to 10 minutes, right over here in the very beginning, the rates of change, and actually 10 to 20 as well, the rates of change of the non-insulated cup are of greater magnitude. They are greater. I mean, that drop is much steeper. But then in the interval from 40 to 50 and 50 to 60, kind of here towards the end, from 40 to 50 and 50 to 60, the rate of change of the insulated sample is greater because the insulated sample is still dropping over there. And this one is pretty much staying the same. So that's why D is the correct answer. All the other answers there have the intervals kind of mixed up, and they just don't match up with what the picture says. Number 28, coordinate geometry problem. We got some sort of shape on here. Let's read it. We have ABCD is a square and point E is at the center. So right there is the center of the square. One thing I kind of noticed right away is that these grid lines here are going by 2s. So be kind of careful on that. Don't think that each square is worth 1 because each square is worth 2. And it says the coordinates of points C and E are 7, 2, and 1, 0. So this point is 7, 2, and this point right here is at 1, 0. And it says, which of the following is an equation of a line that passes through points B and D? Well, here's point B, or D, and here's point B. So I'm trying to figure out, what is the equation of a line that goes through these 2 points? Now, I do know one thing about a square. In every square out there, if you cut corner to corner, the diagonals, they do cross each other at each other's midpoints. So that's a fact that I guess it isn't super critical, but it is true. So I know this is going to kind of cut down something like that. Well, if I want to find the equation of line BD, there's basically 2 things I need. When I look down here at the bottom, all of these people right here are in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. And you need to know the key features here. So m represents the slope, and b represents where you cross the y-axis. Now this line's dropping pretty fast. Let's kind of focus on, it started at, let's see, left 1 up 6. So it started at -1 comma 6, and then it ends up down here at, it looks like that would be 3 negative 6. So my 2 points are going from -1 6 to 3 negative 6. Now a couple different ways I could do slope. I could do rise over run. I could do the change in y over the change in x. You know, I know a lot of people, slope is the subtract the y's, subtract the x's, which basically turns out to be rise over run. If I do it that way, you know, the second y minus the first y, -6 minus 6, and then the second x minus the first x, 3 minus -1. If I'm careful here subtracting these integers, I'm going to get -12 divided by 4, which is just a slope of 3. So my slope, or my m, is -3. That wipes out C and D, because those lines have a slope of -1/3, which means they're dropping 1 and running 3, which is going to make for a pretty flat line. My lines are dropping 3, running 1, which is going to be pretty steep, and it matches with our red line up above. Now the only other thing I notice here is I notice we're crossing the y-axis right in this spot, you know, right there, which looks like it's at +3. Well, this problem right here crosses at -1, which would be way down here. That doesn't look correct to me. So by deductive reasoning, I'm going to say it's B, but if I actually work that out and I do a little bit of distributing here, I distribute there and I distribute there, I get y equals -3x plus 3, and now it matches what I want. It's got the right slope, it's got the right y-intercept chilling right there. So I believe the correct answer for this one is B. Number 29, system of equations. Looks a little bit messier than usual. So let's kind of go through and figure out what we need to do. So I see we have y equals 3, which is linear. It's just a straight line. And then we have y equals ax squared plus b, which is a parabola. So I have a line and a parabola crossing. Over here to the left, I'm just going to kind of give you some examples. Like, so normally we'll have some sort of line, and you may have a parabola, and it crosses in 2 different places, which means it has 2 solutions. Now you also could have, a line, and you could have a parabola, not touch it at all, and that's going to have 0 solutions. You may have a parabola come down and just nick it, and that would be 1 solution. So there's lots of different ways to get 1 solution, 0 solutions, or 2 solutions. It's basically how many times they intersect each other. So I'm going to kind of focus on the graph of this thing because I think it'll go a little bit quicker and it's a little bit smoother. So we have our grid here, and I know this first one. I know what y equals 3 looks like. It's a horizontal line that crosses at 3. So it goes up 1, 2, 3, and we have this line going across right there. Well, looking at the bottom part, looking at this y equals ax squared plus b, I need to know what the a and what the b, how they affect this thing. So kind of moving back over here to the left, kind of do some scratch work over here. Normally when you do y equals x squared, well, what that normally looks like is it's a bowl that opens up, and its vertex is right there at 0. Crosses right here at 0. Now, if I want to shift that thing up, I'm going to add a number to the back, like 2. And that'll shift it up 2 units, and it'll still be a bowl going up, just shift it up 2. If I want to move it down, you know, I go -2, and then it moves it down. Still going up, but it's down at -2. So the back number controls whether it's going to move up or down, shifted. Now, I need to understand that the parent version, when you put a negative number in front, so y equals -x squared, well, what that does is that flips it over to where now our parabola is actually opening down instead of up. That's the effect of putting a negative number in front of the x squared. And then if I want to combine things, I can say, hey, well, how about we move it up 2? So now it's still coming down, but it's moved up 2. So big thing I'm trying to show you is over here is whether it's going to shift up or down. And this front number tells me whether it's going to be, the bowl's going to open up or down, not where it's shifted. So let's kind of go back over here and let's get after this problem and see what's going on. So we had our line y equals 3 right here. And let's just kind of see what would happen if we put different a's and b's in. So an a of -2 means we're going to have a -2 in front. So that means it's going to kind of open down. It's going to be like a rainbow looking thing. And then the b tells me that we're going to move up 2 units. So, because b is +2 at the back side. So this thing from 0, 0 is going to go up 2 units, but open down. Well, that's a problem. We don't intersect our line, so this would have 0 solutions, so it can't be the answer because it says we want to have exactly 2 real solutions. So let's go down to the next choice. Let's go down here to b. A is -2, so again it's going to open down. But now we're going to go up 4 units. So from here we're going to go up 1, 2, 3, 4. We're going to open down. Hey, I think that's our guy right there. That is the correct answer because now I have 2 real solutions. Let me just kind of prove to you on the other ones that they don't work. So since a is 2, that means our number in front is going to be positive. So it's going to be more of a bowl like that. And it's going to go up 4. So from 0, 0, if I go up 1, 2, 3, 4, and I'm a bowl going up, again, I don't touch my line. Remember, this is the y equals 3 line that we're trying to intersect at 2 different places. Part C definitely didn't do that. And then let's just double check the last one to prove that we were right. If our A number, if our front number is positive, it's going to be a bowl going up. And if we move up 3 units, well, from 0, 0, I move up 1, 2, 3, and it's a bowl kind of coming up like that. Well, it only touched at one place, so this would only have one solution. This had 0. So you're out as well. So the correct answer there is B. Number 30, probably one of the toughest questions on this test. I'm going to try to cheat it. I'm going to try to just kind of use some good old-fashioned guessing and at least whittle it down to 2 and maybe even get lucky and get the right one. And then I'm actually going to do it kind of hardcore using a bunch of knowledge of geometry and special right triangle ratios and things of that nature. So let's try to cheat it first. This is the calculator portion. So first thing I'm going to do is I'm going to go ahead down to these answers and I'm going to kind of change them to, I'm going to go 64 times radical 3. And I figure out that that is somewhere in the neighborhood of, it looks like 110. And then 16 times square root of 3 is about 28. And then it says the area of the hexagon, so the area of that hexagon inside there is 384 times radical 3, which is 665. All right. So this entire hexagon, this blue area right here, is 665 roughly. And we are supposed to figure out, it says the figure above shows a regular hexagon. Regular just means that all sides and angles are equal. And it has a square hooked to it that's got the same side length. So they're wanting me to find what is the area of the red square. Well, I'm going to just kind of try to cheat this problem. I'm going to flip that red square right inside here. And I'm going to try to make it be roughly about the same amount. And I'm going to bring this side in, make it be roughly the same amount. And, if that whole blue area is 665, let's just see what maybe this red area looks like. Well, I think 28 is extremely too small. That looks like it's way bigger than 28 if the blue is 665. And I also think 110 is out of the question. Now we're kind of in a dogfight. I'm not quite sure between these two. you know, looking at B, 192 compared to 665, that's less than 1/3. And I don't know, man, that square to me looks like it's might be more than 1/3. You know, 256 it's less than half, but bigger than 1/3. So I'm not positive, but I'm kind of leaning towards A. But you know, if that's as good as you can do, hey, that's fine. Unless you're trying to get a perfect on a question like number 30, just getting it down to a 50-50 gives you a big advantage, gives you an edge. But let's go after it and let's get it for real. So a couple things we need to know. First thing is, when you want to find the area of a hexagon, you need to first break it into triangles. So I'm going to come right out of the center here, and these kind of spoke-like things are going to break it up into 6 triangles that are all congruent to each other. Now they told me the full area was 384 radical 3. So I'm going to do 384 radical 3, and I'm going to divide that thing by 6 to find out the area of one triangle. So 6 goes into 38 6 times, which leaves 2, 24. So it looks like every single sliver, every single triangle is 64 radical 3. That's how much one blue triangle is. All right. So let's kind of, now that we have that number, I want to kind of focus on just one triangle. And it said that every single side here was A. And we know that our square is also side A. And this is A because it's a square. So our ultimate area is A squared is going to answer this question for me. Well, let's try to figure this thing out. So I'm going to zoom in on this triangle. I'm going to yank it out. I'm going to zoom right in here. And the first thing that I need to know is that circles are 360 degrees. So when I divide 360 degrees all the way around, that forces every single one of these pieces to be 60. All right. So every piece is going to be 60. And then I'm going to drop this height down right here in this triangle, which is going to split that 60 into 30 and 30. And if I drop it straight down, like over here, that should be at 90 degrees. And that tells me that because all triangles are 180, that tells me that this must be 60. All right. Well, I know that the area of a triangle is 1/2 base times height. Okay. And I've shown over here that I know the area of each triangle to be 64 radical 3. So I need to figure out what the base and what the height are of each triangle. Well, the base I know already. The base of this triangle is just A. So I'm going to kind of wipe this B out of here. And I'm just going to put an A in there. Now, the toughest part of this whole problem is I need to figure out what the height is of the triangle. I need to figure out this leg right here, which is where people struggle. So here's where you got to kind of know some special right triangle rules. So I come in and I'm going to kind of erase this side. But the 30, 60, 90 is a special right triangle. And there is a rule, and let me just kind of go off the grid and use some numbers just to make it a little bit more simple. But the 30, 60, 90, the ratio is whatever the smallest side is across from the 30, let's say it's 1. The hypotenuse is exactly double that side, which makes sense because it's half of the equilateral triangle. But then this side right here, the side opposite the 60, is always the smallest side times the radical 3. So that's the rule that you need to know. It's always times radical 3. So on our triangle here, if this whole base down here was A, that means this little piece over here is A chopped in half, or A over 2, which means this piece is A over 2 times radical 3, because that's the rule for 30, 60, 90 triangles. So I'm going to replace that H with A over 2 radical 3. And now I have some algebra to do. I have some multiplying to do. So let's kind of get after this. So I'm going to multiply the top. Maybe I'll just put a 1 underneath this A and a 1 underneath there. I'm going to multiply all the way across the top. So 1 times a times radical 3. That's a squared radical 3 all over 2 times 1 times 2 times 1 is 4 equals 64 radical 3. So I have a radical 3 on both sides. I'm going to cancel those guys out. Makes it look a little bit cleaner. Now to get rid of the divide by 4, I'm going to multiply 4 by this side. I'm going to multiply 4 by that side. And I get a squared equals 64 times 4 is 128, 256. And hey, that's what we were after. The area of the square was a squared. So I now know the correct answer was 256. So my guess had me close, but we've now officially proven that. That's a tough problem, though, if you don't know the properties of right triangles, 30, 60, 90s. And then sometimes you need to know the 45, 45, 90.